Notes for Statistics Lesson 6.5, Assessing Normality. One objective, develop the ability to examine histograms, outliers, and normal quantile plots to determine whether sample data appears to be from a population having a distribution that is approximately normal. In this lesson, we present criteria for determining whether the requirement of a normal distribution is satisfied. The criteria involve 1, visual inspection of a histogram to see if it is roughly bell-shaped, 2, identifying any outliers, and 3, constructing a normal quantile plot. Normal quantile plot, normal probability plot, is a graph of points x, y, where each x value is from the original set of sample data and each y value is a corresponding z-score that is expected from the standard normal distribution. All right, let me give you an example, and you've seen it a little bit before, but let me give you another example. All right, I put some IQ data in here from one of the data sets, and what you would do, first you input your data into a spreadsheet, and then let's make this little thing here. The next step would be to make you a histogram. All right, so we'll go Menu, 1 for plot type, 2 for histogram, and we'll take a rough look at it. Well, we'd have to dress it up some and whatnot, but we might, that doesn't look like an outlier, that doesn't really look like an outlier. And you could, if you wasn't sure, menu, and a real quick way is a box plot. And see it's not, oh, it's looking like it might have 4 outliers. Okay, so that kind of fooled you a little bit. Might have 4 outliers. So next, let's go and let's make it a normal probability plot. Okay, and then see, it's pretty close to the straight line. Pretty close. So you know, there's some other tests that you could do, like the chi-square goodness of fit, the Liphoforce test, Anderson-Darling test, that you might try to see if that is truly a comes from a normal distribution. All right, so you know there's some gray area there, I guess. Procedure for determining whether it is reasonable to assume that the sample data are from a population having a normal distribution. Construct a histogram, which we did just a second ago. If the histogram departs dramatically from a bell shape, conclude that the data do not have a normal distribution. So let's look at that again. Let's make it back into a histogram. Okay, and so it looks like there might be, and since there's 5, you know, that says 2, and there's 1 there. So this may not be from a normal. Okay, and then the next step, identify outliers, which we just did. If there is more than 1 outlier present, conclude that the data might not have a normal distribution. If the histogram is basically symmetric and the number of outliers is 0, 1, generate a normal quantile plot. Okay, and we've done that. All right, histogram and normal quantile plots. Now, yes, this says IQ, but that's not actually the same data. Okay, and you take a look at it and see it. That is good. That means that this data is from a a normal distribution, okay? Looks like there might be, but there's like 2 or 3 over here, and it's all pretty much together. So it might, that is from a normal distribution. Now, this one here is a uniform distribution. And see how the normal quantile plot, they're all pretty close, but there's definitely a pattern, maybe a snake pattern or something like that, where when you looked at the other one, when you looked at this one here, there was definitely a pattern. It was all in a straight line, okay? And they were all right on the line. You typically don't find them you typically don't find them this good unless you have a whole lot of data. All right. So when you see something like that, you can think it's probably from a uniform. Here, histogram and normal quarter, this one is skewed. So when you do your normal and see not what one's on the line, and most of them, and it's you can tell that's skewed to the right, okay? Construction of a normal quantile plot. Sort the data by arranging the values in order from lowest to highest. With the sample size of n, each value represents a portion of 1/n of the sample. Using the known sample size n, find the values 1 over 2 times n, 3 over 2 times n, 5 over 2 times n, and so on until you get n values. Use the standard normal distribution to find z-scores corresponding to the cumulative left areas found in step 2. Match the original sorted data values with their corresponding z-scores found in step 3. Then plot the points x, y, where each x is an original sample value and y is the corresponding z-score. Examine the normal quantile plot. Conclude that the population has a normal distribution if the patterns of points is reasonably close to a straight line, and the points do not show some symmetric pattern that is not a straight line pattern. Now, the first time you read this, it might be a little bit confusing. So let's do an example. Let's consider these 5 values, 125, 229, 236, 257, 234. With only 5 values, a histogram will not be very helpful in determining the distribution of the data. Instead, construct a normal quantile plot for these 5 values and determine whether they appear to come from a population that is normally distributed. So we only have 5 values. Okay. I like to do it kind of as a, let's see here. I like to do it kind of as a table. So and I got 5 values. So let me see here. What were my, I need to put them in order. Okay, so I got 125, 229, 234, 236, and 257. All right, let's see here. I'm going to draw some lines across here, so maybe make it a little bit easier to keep up with. And that's 229 there. All right, so that's our first. Then we've got 1, and we got 1, 2, 3, 4, 5. 1 over 2 times 5. So that's going to be 1/10. All right. 3, and I'm following that formula, 2, and that's going to be 3/10. 5 over 2 times 5, and that's going to be 5/10, or 1/2. 7 over 2 times 5, and that's going to be 7/10. And then 9 over 2 times 5 is going to be 9/10. Okay, 9/10. So what do we got here? We have the x, and then we have the area. Okay, and now we can compute the z that goes with it. Okay, so let's see here. Now you can look those up. 1/10, that would be 0.1, or you can use your graphing calculator. I'm going to use the graphing calculator. So I'm going to press tab here, and you can see I've already done them. But let's see here. Menu 1. We'll clear the history, and we'll do it again. We'll do it together. Menu 553. The area is going to be 0.1, or 1 divided by 10. And we get negative 1.28. So you got negative 1.28. Negative 1.28. And then 3/10, that's going to be 0.3. So menu 553.3, and that's negative 0.52. Negative 0.52. Now this is 5/10 or 1/2. So what do you think that's going to be? Menu 553, and it's 0.5. Yes, 0. 0. And then remember, the standard normal curve is symmetric. So this is going to be 0.52, and this is going to be 1.28. I know you probably don't believe me, but let's try. Menu 553, we'll put in 0.7. Oh, 0.52. And then menu 553.9, 1.28. All right, good. So now we're going to have our ordered pairs. And we're going to have our ordered pairs, and that's going to be x, y. And those ordered pairs are going to be 125, comma, negative 1.28. And we're going to have 229, negative 0.52. We're going to have 234, and that's going to be 0. 236, and that's going to be 0.52. And the last one's going to be 257 and 1.28. All right, good. So let's go plot those points. Let's go plot those points. We need a new let's see here. Let's get us one. Let's call this, we'll be real creative. We'll call it A. All right, we'll call it, oh, I've already used A, it looks like. So let's go up here and let's call it D. Let's see here. Well, that's the numbers, isn't it? That's the numbers. We'll call it D. We'll call it D. And then we had 125, 125, 229, 234, 236, 257. All right, and then we'll call this G. And that's going to be negative 1.28, negative 0.52, 0.52, 1.28, and we have our numbers. So we need to graph those. On graph, and then we had D and G. D and G. All right. And we need to draw a line through here. So we'll just use a regression line. And that would be menu, analyze, 4, 6, and then linear. Okay. And then if you want, you could move it around a little bit if you think you can do it better. All right. And there you go. That is making a quartile plot by hand, quantile plot by hand. This data here, these right here, came from Old Faithful here. Now there's actually 250. So we'll see just how good it is. We'll go on. We'll see if it actually came from a normal distribution. All right, so this is Old Faithful. There we go. And then, so that's that. Let's make it our histogram. Menu, plot type, histogram. Now see, you got this right over here, and that looks kind of normal. Then over here, this is, like kind of skewing it to the left some. All right, so I don't think so. So let's menu, and then plot type, normal probability plot type. Okay, you see, look here, here's your line. Most of them aren't really near the line. Plus there's a definite pattern here, okay? So that data is definitely skewed, and it's skewed to the left. All right. Good job, folks. See you in class tomorrow, and y'all have a wonderful evening.